Welcome to this discussion about inverse trigonometric functions. So this video is going to focus on the inverse sine function exclusively. We're going to define that function and then see how we can use it in a couple of different ways. So let's go ahead and talk a little bit about the inverse of the sine function. So in order to really kind of understand what the inverse of the sine function is, or the inverse sine function, you want to first remember that the graph of y equals sine of x looks like this. It's this wavy function here, hills and valleys, right? And then you also want to remember what we know about functions and their inverses. Remember that if a function has an inverse that is also a function, it must pass the horizontal line test. Okay, so another thing that we want to remember is if there is a point xy on a specific graph of a function, then the coordinate yx will be on the graph of f inverse of x. And what that means is if you have a point like 2, 5 on the graph of a function, that function has an inverse that's also a function, then the graph of that inverse will have the coordinate 5, 2 on that graph. Another thing that we want to remember is that the graph of f inverse of x is a reflection of the graph of f of x over the line y equals x. Okay, so remembering those things, I want you to look at this graph and make an educated guess on if you think that the function y equals sine of x has an inverse that's a function. And if you were to say, as we have it now, the answer is no, that would be true because you can see that pretty much anywhere that you put a horizontal line, you're going to fail the horizontal line test. Okay, so what we need to do to handle this, we're going to restrict the domain of the function y equals sine of x so that it will pass the horizontal line test. So we're going to focus our attention on just a specific piece of the graph of y equals sine of x so we can define y equals sine inverse of x. So we want a piece of this graph so that it will pass the horizontal line test. So there are several different ways that we could do this, but the way that we will do this is to just focus our attention on the interval from negative pi over 2 to pi over 2. All right, so just this little interval right here. Okay, and so if I restrict the graph of y equals sine of x to just that portion of its domain, now do you see that it will pass the horizontal line test, and we can actually say that this piece does have an inverse function. That this piece does have an inverse that is a function. Let's explore a little bit about what the graph of the inverse of the sine function looks like. So in order to do that, we're going to fill in this table and plot some points and kind of look at our graph. And notice that I've chosen values for our input that are within that restricted domain, right? And they're things that you should know the sign of. So we do know the sign of negative pi over 2, right, to be negative 1. We don't know the sign of negative pi over 3 to be negative rad 3 over 2. Negative pi over 4 is negative rad 2 over 2. Negative pi over 6 is negative 1/2. The sign of 0 is 0. And then all the rest of these positive angles will have the same values as above, but they're positive counterparts. All right, and so if I'm looking at these coordinates, we're just looking at a specific part of the graph of y equals sine of x. we can see these coordinates, and you can see kind of the beginning of the sine curve starting to emerge, right? And if we connect the dots, we have just that little piece. Now, the reason why we're looking at just this little piece and these coordinates is because, remember, we talked about if an xy coordinate is on the graph of a function, then we can find the corresponding point on the inverse function by just swapping the x and the y. So I've gone ahead and filled in these x values here with what our outputs were here, and we can go ahead and quickly fill in our outputs here with what were the inputs here. So let's go ahead and do that. Let's fill those all into our table. And then we're going to go ahead and plot those points on a graph. And it kind of looks similar, but you can see that the curve is a little bit different. All right, and so as we connect those dots, we can see that curve emerging, and it does have that increasing characteristic, but the curvature is a little bit different. All right, so that gives you an idea of what that looks like. And so let's actually define the inverse of the sine function, all right? The inverse sine function uses the notation arc sine of x or sine inverse of x. Okay, so if we're looking at a specific function, it would be f of x is equal to this or y is equal to this, all right? And it is defined to be the inverse of the sine function that has a restricted domain of negative pi over 2 to pi over 2. Okay. Now this implies that y equals the sine inverse of x actually means x equals the sine of y. And it means that with the following restrictions, right? The restrictions on y in our sine inverse function are going to be negative pi over 2 to pi over 2. Okay, and so I want you to look at this, right? Because the restrictions on the range of our sine inverse functions are the same as the restrictions on the domain of the original sine function, right? And so that means that the restrictions on x of the sine inverse function are going to be from -1 to 1, and those are the same as the restrictions on the range of our original sine function. Okay, so we're only using a limited amount of the domain of our original sine function, right? Okay, so that limits our range as well. All right, so let's go ahead and use the inverse sine function. And I tried to make this so that you could understand the thought process as we are coming up with some evaluations. So there's really a couple of different things that we're going to do with the inverse sine function. And one is we're going to use some familiar angles from our unit circle to find the exact value of the inverse sine function. Okay, so remember, this is important, that the restricted range for the sine function is negative pi over 2 to pi over 2. And I want you to think about where is that on your unit circle. Okay, where is it? Top, bottom, left, right? And this is the right half of the unit circle. So we're going to focus our attention on this right half of the unit circle. Now notice that I changed the radian values in this fourth quadrant to reflect the negative versions of those angles, right? Because normally we talk about this as 3 pi over 2 and 5 pi over 3 and 7 pi over 4 and 11 pi over 6. But with our restricted range of this sine inverse function being negative pi over 2 to pi over 2, we're going to call these angles by their proper names for this inverse function. All right, so here's an example. We want to find the exact value of the sine inverse of rad 3 over 2. Okay, so what does that mean? Whenever you see this notation, you are thinking this is the output of this notation is an angle of some kind. All right, so the first thing you're thinking of is what angle measure on this interval that I know that my sine inverse is restricted to has a sine of rad 3 over 2. Okay, so what I'm thinking about is on the right side of my unit circle, that takes that into account, one of these angles has a y value of rad 3 over 2. And so I'm thinking in my mind, or I'm looking at this picture for an angle measure that has a sine of rad 3 over 2. And if you look and find it, you should find it right about here. Right? Okay, and so all you're doing once you find it is pulling the angle measure where it occurs. And you can say that that would be pi over 3. Okay, here's another example. Find the exact value of sine inverse of negative 1/2. Okay, the area we're looking at does not change. It's still negative pi over 2 to pi over 2. We're looking for something now that has a y value in our coordinates of negative 1/2. Can you find it? If you looked here, you should be correct. And this is important. You want to identify it with the proper radian measure. Okay, this is 11 pi over 6, but our restricted domain is between negative pi over 2 and pi over 2, so we call this angle negative pi over 6. All right, let's do a couple more, and I'll go a little quicker with those. All right, so here we go. What's the exact value of sine inverse of 0? All right. On that right-hand side of the unit circle, which angle has a y value as a coordinate of 0? And if you identified that as 0 radians, you would be correct. And last, find the exact value of sine inverse of negative 1. Look for an angle measure that has a y value of negative 1. And there it is, down there at negative pi over 2. All right, so that's one thing that we would be wanting to be able to do with the inverse sine function. And then another thing we would want to be able to do is use our technology to identify approximations for the inverse sine function for specific things that are not on the unit circle. Okay, so we want to make sure that our calculator is in radian mode, and then we want to know how to use our calculator in such a way that is going to give us the correct output. So let's start with one. Find the value of sine inverse of 3/8. So you're just going to find on your calculator the sine inverse key. And usually it's the second function for the sine key. So you would just do sine inverse of 3/8, making sure your calculator's in radian mode. And you should get an answer of 0.3844. And remember, that means that the sine of 0.3844 should equal 3/8. And so it's worth it to just crunch it real quick and verify that that's true. How about this one? The sine inverse of 0.8421. Same thing. Do second sine on your calculator of 0.8421. You should get an answer of 1.0012 as the sine inverse. And remember, that means that the sine of that, sine of 1.0012 radians, is equal to 0.8421. Go ahead and check it. For this last example, I'd like you to try it on your own. See what you get from your calculator. All right, find the value of sine inverse of 1.294. What did you get? So most likely you got an error, right? Because we need to remember that our restricted input for the sine inverse function is between -1, and +1. And this input is outside of that window, right? It's greater than 1. So no, you can't actually evaluate this, so there's no solution. It's undefined. So that wraps up this video on inverse sine function. Next video, we'll talk about the inverse cosine function. I'll see you then.